As we talked about last time, object orientation takes the best small details out of procedural programming and finds a different way to organize it. So instead of having these list of procedures, we group them together into components that allow us to merge and mold data and functionality into a higher functioning, it's a little bit smarter piece of software. So in our system before, we had some very clear objects we saw before. We saw these pictures of things before. And the mantra of being an object and the idea of software is objects know things, objects do things, and objects communicate with other objects. So to be an object, I'm going to be more than just a piece of data floating around the system. I'm going to be a whole being of I have some information, I do stuff with my information, I provide services to other people, I make things happen. And so in our system, we could see before we had eggs, we had bowls, we had pans, we had plates. These were all physical, tangible things. Because remember, we said programs don't come out of thin air. Programs come based off of the real world. And if we can find a way to represent those things, model them in the real world in our software, then we have an interesting way of creating the same application, of managing the same application. So think of it this way. When we went from shopping at the brick and mortar store to shopping online, and you go pick some stuff that you want to buy but haven't paid for yet, what do you put it in online? Well, you put in the same thing online that you put it in when you go to the store. You put it in the shopping cart. Why? Because it's familiar. It's a familiar notion. If you started building computers before you built brick and mortar stores, would you call it a shopping cart? Maybe not. I mean, if you went from hunter-gatherer, where you basically picked berries and put them in your shirt pouch, maybe you would have been called add to the shirt pouch instead, right? You're modeling it based off the real world. So when we move from procedural programming into objects, procedures focus on what the code is doing, the functional aspect of it. And they're easy to solve for a single problem. I just break down a problem using functional decomposition, and I end up with a series of steps. But they don't necessarily facilitate easy reuse across many problems. The way I cook an egg might be pretty different from the way I cook bacon, which might be different from the way I cook a steak. So each of the, I'm really meat eater today. For the different way I cook asparagus, there you go. I might fry up some asparagus. I'm actually frying some butternut squash later tonight, so I'm looking forward to that. But anyway, our objects are a little bit different. Our objects are things that are always there. When you talk about your bank account, you always have an account. You always have a deposit. You always have a transaction. The rules around that bank account probably are going to change over time. There might be different times where I have different promotions going on, or different rules about deposit limits, or maybe different cashback scenarios where if I use this for this, I get extra points or something like that. Free toaster for opening the account. Those functional things come and go. But the objects are the same. They provide a consistent place where I can group together data and functionality to do the basic core operations of my system. And so if I do the same program we created for making eggs in object orientation, some stuff changes, but not everything. The core of the flow is still the same. I crack eggs, I put them in a bowl, I put them in a pan, I serve them up. The core of that's the same. But the difference is, instead of having some magical, mystical, outside third-party person that does the work, the objects I created in the system are the ones I asked to do the work. So here, instead of randomly saying mix contents in a bowl, I go to the bowl and I add in an ingredient. And where do I get the ingredient from? I go to the egg. Instead of having some outside external crack egg method, I go to the egg and I ask the egg, hey, crack yourself and give me your innards. And maybe I have methods inside of there that's not just all the innards. I can say get the yolk, or I can say get the white separately. So I can start to create recipes based off these smart eggs that will give me the piece I want specifically. I don't have to do extra third-party external manipulations. Again, then I go to the bowl. Notice the bowl has an add method. I could add eggs, I could add milk, I could add some fresh herbs, I could add some whatever I want to my scrambled eggs. And then when I'm all said and done, I have this reusable service in the bowl calling mix the contents. Whatever I put in the bowl, I could put, bacon. I could put tofu. I could put whatever I want inside of there. Doesn't have to even be eggs. I could be making cookies. Mix the contents up. And then I take the bowl, I get the contents, in the next line here, get that contents and put it into the pan. So the pan, I'm saying fry up whatever I'm going to hand to you right now. The parameter I'm going to hand to you is the contents of the bowl. And then the plate is going to serve whatever it gets handed to, which is the contents of the pan. So the biggest differences here is I have an object I'm asking to do the work. Just like when you go get your taxes done, you start with your accountant object and say, accountant, please do my taxes. You don't just say to the heavens, I need my taxes done, and then they magically get done. You have an object, a person you go and see to get that work done. So fundamentally what's different here is I ask an object to do work. I need to get that object, and that object knows stuff. The object knows. The egg knows it has contents. It knows it has a yolk. It knows it has weights. It knows how to get those things to that. And it has the work to allow you to do that. It controls its own state. If I get the contents of an egg, it becomes a shell. If I go and ask the egg to get contents again, it can't generate that again. It already gave them away. And so it would give you an error message or something like that. It's smart. And so I don't have to pass all the data around. Like with the bowl, I put stuff in it, and when I mix the contents, I don't have to have a list of all the things I'm going to put into it. Hey, whatever's in the bowl. The pan, whatever's in the bowl, I put the pan, I fry it, and the pan fries whatever's in it. Fry whatever it wants to. So the great part about this is I can do interesting stuff with now reusable pieces. So I want breakfast for two now. I can come in and I can have a bowl. I can have a pan. I can reuse these objects. I have the first egg in the first plate. I take the bowl. I take the first egg. I mix the contents. I fry up the contents. I take the first plate. I serve the contents of the pan. Then I go get a second egg and a second plate. Take the same bowl, get the egg innards, mix the contents, fry up that in the pan, get the second one. So now I can have flexible code. I have easy to move around pieces. I can reuse the pieces that make the most sense, and I can create new ones when I need to create new ones there. We're not going to share an egg, but no, you don't care about sharing a pan. Now, within object orientation, we talk about objects a lot, but objects have this template called a class. When we say the word object, an object is a specific instance of data. In this class, there's a number of you who are called students. Now, if I referred to you as student 1, student 2, student 3, you'd probably be annoyed pretty quick. Each of you has a name. But as far as when we formulate the idea of a class, there's a teacher, there's a student. I'm just a number as far as the teaching goes. There's a lot of people who teach this class. So the idea of, and I shouldn't use let me use the word course. There's a lot of people who use this course, teach this course. So the idea of a class in an object-oriented language is it's the code that organizes and defines what objects do, what they are. And so a specific object has, like a product, a serial number, one that you get to buy and take home. You are an individual student with a name and a student ID. The name's probably more important. I'm a teacher with a name, that's unique to me as well. And so that does not mean we don't do similar functions. You get grades from me just like you get grades from every other teacher you've taken in every other class through the same system, and it looks the same no matter who's grading it because it shows up in the web page at the same spot. In that software out there, there's a representation of me, the teacher, there's a representation of you, the student, and that's defined as a class. And the class defines the data, it defines the behavior, and we'll learn a lot more about that as we go. But the class is related to the object, but distinctly different from the object. Now, the class has become the building block of what object-oriented software is. You could say class-oriented software, but it's, again, the objects are what's important. If I had a class for a student, and I had a class for a teacher, and I came into a course, and there was one student, one teacher, it wouldn't be very interesting or profitable for most universities. It'd be very expensive for the students, at least. So the idea of when I teach a course, I have many object instances which are students. Sometimes more than one teacher in some classes as well. That happens occasionally. So the idea behind it is we have this separation between real-time, runtime data versus the structure of this data, which is similar in groupings. So the main principle of building objects is this idea of encapsulation. Encapsulation allows us to wrap up data and functionality together. Data and functionality grouped up mean that I can hide certain pieces of data and have functionality that's only offered in certain ways to collect and work with that data. So I can have certain protections. I can keep the details of how things work. As an example of that, we had a bowl earlier. Now we can put stuff in a bowl. The bowl we were talking about, we were kind of thinking about food. So I could say, hey, I have green beans in a bowl. I can put popcorn in a bowl. I can have dog food bowls. I can put fish in a bowl. They're all things, they're valid uses of bowl. You can put pretty much anything in a bowl. You could put rocks in a bowl. You could put marbles in a bowl. You could put anything you can think of, really. Now, this leads to the notion in languages like Java called strong typing. Strong typing means that I want to very strongly understand what data goes into that container. There's certain things that have to be text, there's certain things that have to be numbers, and so we want to make sure when I'm dealing with something, I don't put something very dangerous in like for a frying pan. If I put gasoline in a frying pan, that's a really bad thing. So strong typing allows me to define what objects exist in the world, what data is allowed to be passed around in the world. So that's another strong, important concept we want to get to in coding in general. So when I call a method, the method comes from an object. So the method in object-oriented programming equates to a procedure in other languages. Each of the procedures then has data types. And so when I call a method like you'll see later, system.println, I pass in a string. When I pass in bool.add, I have some type that defines what goes inside of that. And typically it's going to be something like food or hazardous material or something like that. And so you'll learn about this concept of inheritance, where you have this idea of a bowl and it's pretty flexible. I can put anything in a bowl. And so I can have a very flexible, like put whatever you want to here, but I don't care about that. A pan, as we said, I want to put food in a really hot pan, but I don't want to put gasoline. I don't want to put fireworks. I don't put something dangerous in there. So I have to have something that's maybe non-flammable that goes in a pan. And it becomes like if you want to do a flambe, how do you work around that? Well, maybe you have a special type of pan or something like that. But the idea of inheritance is it allows us to group objects together to make certain categories of objects. And again, you'll learn way more about inheritance than this, but I want to introduce the concept to you. It's the idea of grouping things together to share behavior, to share descriptions and stuff like that. And so the last important piece of all of our system is we saw that our objects had relations. When we group things into a category, we have things like food, and there's different types of food. Food's related because bananas and onion rings and carrots and burgers and fries, they all can be substituted for each other. So we put stuff on a plate, we want to put food on a plate. We don't want to serve something disgusting, I'm not even going to come up with an example, on a plate to people. We want to have it be some category of food. So by using the definition of classes and by using strong typing, it allows us to group these things together and create these relationships. And so that way, when the pan works with the plate, we know what goes into the pan as food, what comes out of the pan as food, what goes onto the plate as food. But a bowl, we can be more flexible. We can have fish in a bowl. We can have maybe dirty sink water in a bowl while we're off cleaning something else, stuff like that. So there's certain different ways we can work with things. Bowls might be more flexible than pans and plates, for instance. All right, so this is all really high-level, big picture. There's so much more you're going to learn through this class and through upcoming classes as well. You get to a class couple ones down the road, and you'll learn all about inheritance and all the details of how that works and stuff. But you need to get used to the idea you're going to constantly be growing a little bit. Think of your education as a spiral. You're going to come back to these concepts over and over and over again, getting deeper or broader, however you want to look at it, learning more and more and more. You're going to be reading more about this stuff. You're going to be searching and asking questions about this stuff. And that's going to take you into the assignments. So do these homework assignments, but don't stop there. Go deeper to what you're seeing. Play with stuff. Break stuff. That's what coding's all about, is trying stuff out and figuring it out from there. So we're going to do some of that. So stick with us. we're going to get in hands-on, and this is going to be great. You're going to learn so much about Java.